So today I'm basically going to do an overview of calciumImagingAnalysis, or CIAPKG. I'll go through kind of the GitHub and the documentation, kind of update that documentation now. And then I'll do a demo of the GUI mode of CIAPKG, and then a demo of the command line. And then, whenever people have questions, they can just chime in and ask. So as kind of presented yesterday, this was mostly work that was done while I was in Mark Sitz's lab at Stanford. And right now I'm in Alan Bassbaum's lab at UCSF. And so the tool is called calciumImagingAnalysis, and the main things that it does is it does kind of processing of both 1 and 2 photon imaging data sets. Kind of supports multiple cell extraction methods. Can do manual and soon automated classification. There's a cross-section alignment, as well as the batch analysis of basic and arbitrary number of movies once you load it into the class, or if you're using the command line version. And then we recently added the NWB support, and then we're going to be basically further adding NWB support so that more or less all the modules and everything will support it. So for those that we don't do as much custom imaging analysis, so the general overview is that we have incoming video data that we want to process. And this incoming video data, we then want to take this, do the filtering, the pre-processing, motion correction, and then go and get the cell shapes and activity traces. And then after that, do the either manual or automated classification to get rid of things that are not biologically relevant within the source signals. And the last thing usually we want to do is do the cross-section alignment. So actually there's been quite a number of custom imaging tools that have been developed over time. So actually I have this posted online, but basically there's a lot of different tools, and one of the main ones that's also being presented here is both Sweet2P, somewhere on here, and then and Cayman as well. And so this, the inspiration for this initially was a long time ago at the beginning of my grad school. We basically had hundreds of movies, and I wanted a way to batch deal and analyze them. And so the kind of the general overview of how it's working is that you have, you can basically load in your imaging data if it's like an AVI, TIFF, HDF5 formats, and NWB. And then you can do the video processing of these, so different kinds of video processing, spatial filtering, motion correction. And then perhaps what's slightly different than the other tools is that basically from the get-go, this was kind of designed so that you could basically do multiple different cell extractions, which is a fairly important step. And this basically allows you to both do one of our new algorithms called SumX that you should be hearing more about in the future, and then as well as some of the prior algorithms like PCISA, CMS, MFE, and then another algorithm developed in our lab called Extract. And then as well as that, there's kind of steps to do the manual as well as the automated classification. And then to go in and this should be on the GitHub soon, but more tools to basically compare all these different algorithms so that you can more easily determine which is best on your data set, just because in some cases, some algorithms work better than others, depending on kind of the noise signals or other properties of your data sets. And then the last part is doing the cross-section analysis. And then kind of it's built into a class, so you can use it to do downstream analysis, or it's like, for like our recent science paper actually used it to do the analysis. But at the end of the day, once you have the output saying NWB, then you can load it in and do it the analysis wherever you want. So if we go over to the GitHub, what does this look like? And so basically on the GitHub, the whole entire package more or less is in MATLAB. There's certain parts that are in ImageJ, but basically the whole thing is in MATLAB. And if you go through, basically the initial page has like a quick README and overview of how to use the package and what it contains. In particular, for example, if you just want to get started, since MATLAB doesn't quite have the package system in the same way, say, Python does. But it's really easy to actually just load in, say, a package purely from the command line without actually having to go and do the download from the GitHub. So if you just run this command and then run these commands, you'll be set up. And I'll kind of show you that today. And then it contains some additional notes on here, but this is kind of a summary section. Then if you go into this full documentation at the top, this will take you to basically the user guide website. And this contains more extensive documentation on several steps. So there's an individual kind of setup here, some of the notes on the processing, the API, which there'll be more on this, and then some of the help pages. And so for those that don't like to see things in multiple segments, there's basically everything in one entire page. And I think that's basically originally how I'd organize everything, but then I think some people realized at some point that having everything in one page overwhelms people. And so basically there's kind of the quick start, which is similar to what we were seeing before. There's some notes on the installation, just to make it kind of clear for people. And then the repo includes basically 5 example data sets, so 4 of them that are 1 photon, and then 1 of them that's 2 photon, just so that new users can basically get started analyzing and getting a feel for the package. And then I basically include a note on the different dependencies, so both the MATLAB toolboxes, which it checks on initialization for the ones that are important and not, and then for some of the outside tools that are there are dependencies on, and then this will be updated once we have some of our newer algorithms released. And so if you go into the overview, this will basically give you that same data workflow that I showed you, and it'll basically show you the kind of general workflow for the different steps that you need to do in terms of if for most people you want to start by adding whatever folders that have the particular data set that you want to analyze, and then there's steps after that to check and view your movies, to process them, to do the cell extraction, and several steps afterwards. And then so once there's a general overview, and then if you go down basically into the step-by-step, there's more or less what kind of layout for each of the individual processing steps, which is kind of like a general workflow of how to do the processing and analysis. And so I'll basically be going over that after this. And then basically down here, there's a bunch of help pages just for kind of issues and fixes. Every language always has its quirks, and in particular, especially between, for example, OSs. So basically this kind of contains more or less a list of several commonly used ones that I know other users have told me about. And then other than that, there's also several pages on kind of the different aspects of the analysis, and some notes on how to improve it. So for example, with the manual cell sorting, which I'll go over later, there's a fair amount of documentation that basically go over both the interface, as well as some notes on like what are good and bad cells and best practices. So that's kind of the main documentation website. And so we updated that recently to make it a little easier for people to find what's relevant. And then they'll be kind of expanded as more things are added, just to make it clearer for users. All right, so if we pop back over to MATLAB, so the main basis for calciumImagingAnalysis is there's basically 2 underlying ways that you can run it. So one, you can run it either using the underlying functions from the command line, which we'll go over later, and the other is you can run it just by initiating this class. So once you initiate this class, what's going to happen is it'll basically go in and it'll check and load. So it'll initialize some things in the path. It'll basically go in and check all your toolboxes that are available, so some critical ones, and then there's some that are secondary for downstream analysis. And then one other thing that might happen is that since I use ImageJ for some of the displaying of the movies, just because ImageJ is very has a lot of features that I didn't want to basically replicate ImageJ within MATLAB, you'll sometimes have to deal with Java memory issues. So there's ways to get around that it'll bring up and tell you if that ends up being an issue. So once you initialize this class, what you can do is when you just basically type in the class by default, I'm just overriding the display so that it'll show you the main GUI. And within this main GUI, there's several different steps and options. So the main thing here is that usually on the left, you'll basically have a list of all the different methods that you can run that are available on the public repo. And this is on the left. And so you can basically go through and select any of them. And then when you're ready to go, just enter on the keyboard. And if you highlight over the methods, they'll basically give you a tooltip on what each of them means and some more information on them. Then if you go over here to the cell extraction methods, right now, basically there's on the public repo support for all through 4 of these methods, and then we'll be adding in the support, or the support already exists, but we'll be adding it publicly for the other algorithms that we have been developing. For the cell extraction, there's different formats that you can save in. So there's kind of a default format that uses map files that I save in, and then we also added an NWB support. And when you click this, it'll actually pop up a little note to user about the NWB support in terms of how everything is found within the folders that you have. So when it does that, it'll pop you up a little interface that lets you know that the way I organize CIAPKG, because I basically want to batch things in different folders, is that I've more or less used regular expressions to find the files and movies that need to be analyzed within a particular folder. So the assumption for the most part is that an imaging session for a particular animal or subject is within a single folder, and that within those folders, the organization of the movie files follows some regular pattern. And for experimentalists that don't do that, I guess this is a way to force experimentalists to do that. Then the other is that it'll basically go through and make you some notes about the NWB, and by default, they usually store the cell extraction in a separate folder, but this can be changed. So you click OK, and then once you've had movies added, there's different filters that can be useful later on. So what we want to do initially is just to add a folder to the movie, and then add the folder to the class, and then get everything started up. But before we do that, I'm just going to show the setup, because for most people, they'll have to do this step. So if you do this setup, it'll come over and it'll pop up some information. That basically will tell you that it's going to check and download the dependencies like CNMF, CNFE, others. It'll ask you to include folders for the analysis and some additional information. And so when you do this, what it'll look like is indicated here, where it'll basically download Fiji, which you can use in Fiji to open it up in ImageJ or in MATLAB. It'll download the different basically underlying Cayman repositories, as well as CMFE. It'll download some of the test data sets, and then it'll download the dependencies for the NWB. And any of these, if you've already done it or don't want it, you can just select them and get rid of it. And then depending on whether we want to update the repos from the GitHub repositories online, usually it'll skip it if the dependency is already there, or you can basically force it to update to the most recent version. So if we do this, this is the default. It's going to basically go through for CVX that Cayman may or may not still be using, depending on what you're doing within it. It'll basically load through, and what you'll see is that it's basically going to go through, it'll check, if you've already had Fiji, it's going to skip it, it'll download all these dependencies, download all the movies that you need, and then download all the repos that are dependent for NWB. And then when you're done with that, it's going to ask you more or less for what do you want to add folders. So you can do this in several ways. One is if you just have a list of folders. So I tend to basically have more or less list of folders that are either created automatically, or you can use, if you're on Windows, you can use programs like Everything that allow you to really quickly get a list of all your folders. The other is you can do it via GUI. So basically this will pop up a GUI, and you can go in and select your particular folders that you want to add. And then if you're just starting out, you can just hit this, and this will add all the example folders automatically. So we're going to do that. And then, sorry about that. My main monitor is on my other screen, so I'm having to deal with that being pulled over. Okay, and so then the last part is going to ask you for movie information. And so the main idea is that for the, say, the raw files, you usually want a particular name for this. And so this is basically will end up being a regular expression, or just you can put any name that's common within your raw files. And then your process files, if you have them, might have a different regular expression so that you can indicate that here, if you're already starting off with movies that are processed. So now that we've done that, we'll just run it again. And what you can see now is that we have basically a list of different folders added in here, and you can select into the list, or if you have particular animals, it pulls this out from the folder name. But in the future, if there's NWB files, the plan is to pull that information from NWB files. But you can quickly select any of the folders depending on their folder names or their assays, or based off of other selection criteria. And so kind of the main things that we want to do is there's checking for the movie registration. So this is a way to go and check how well a particular filtering algorithm or how well the motion correction is working on your movies in a quick fashion. And then the next after that is basically doing the processing. So we'll quickly go through and I'll show you for the movie registration what this looks like for a particular movie. So I'll select one of the One Photon movies. What this will do is it'll pop up the interface that basically will ask you, and so usually these are just test movies, so I don't run them on the entire movie. So say we're going to take 200 frames of a 1,000 frame movie, and then it'll ask you things like how many number of tests you want to do for your preprocessing or motion correction, and then most of these others you can keep by default as needed. But if you have a lot of movies that you're testing on, a lot of different kind of iterations, I usually just downsample the final result so that it's easier to visualize them all at the same time. So what happens if you click OK, it'll ask you which kind of video player you want to use. So it'll default to the MATLAB if there's any problems with Fiji, but I usually use the ImageJ just because it's a lot easier. So this is the interface that you'll see basically later on when you're doing the full processing, and it's the same exact set of features. So you basically have kind of your just main overview features that you can usually skip. There's things that have to do with the registration or the motion correction, and the underlying basis is TurboReg at the moment. And then there's registration normalization, and then there's movie normalization. And so usually what you want to be doing kind of for these tests is to be looking and comparing the movie normalization or some settings for the registration to make it so you have the best motion correction. So it'll basically continually ask you for the number of test settings you'll do. You can basically just select different options. And you can basically go through and do this for several different options. And then basically you can use this later on to be able to get a sense for which filtering options would be best for your particular movies in hand. So let's select options. And then on the second page, there's more on the downsampling, which is not as much done here. But the thing that might be important for some people's movies is I think for some of the UCLA miniscopes or some other systems, you sometimes have stripes in the movie that you want to remove. So that you can also potentially test that if those are relevant for your imaging movies. Right. And so then what it usually does at this is it just asks you for, you need to set the coordinates when you're doing the motion correction. And what this ends up looking like is you'll basically want to drag and select an area. So a lot of times I won't actually use the entire area to get the initial motion correction coordinates, just because there's sometimes areas that have motion that's independent, say, of the actual underlying brain tissue. For example, if you have dust particles or other things on your grid lens or on your cortical window. So you do this, you select it, and then it's going to go through and basically do the processing for each of the individual movies. And then after that, it's going to basically pop up a movie that will contain all the different motion correction videos. And so if you actually go in and look at the underlying here, so if you actually go in and look at the underlying folder that we're processing, there's particular folder called pre-product run test that's made in each individual folder that you test the process on. And within that, it basically has each of the movies that you process, and it has the settings. And these settings you can load in later at a later stage. So if you did it sort of pre-processing and you liked it, you can go and load it directly from there. And so what this looks like is as indicated here, where you have basically a series of different movies, and the numbers here, 1, 2, 3, will correspond to the numbers here in these folders. So you can go back and check and use those later. And so what this will show you is it'll show you the raw movie initially, indicated here. And so you can basically go through, since it's image J, you can do all the contrast changes that you want. And since it's giving you the raw one, you sometimes have to do that between the different movies, but this is a quick way to get a sense for, is the motion correction working as well? And then how does the filtering look? Then if you click OK, what will happen is it'll close that, and then it'll pop up another movie. And this one will be motion corrected, and it'll be delta over F. So in that case, you can go in and see what it looks like in the case of movies with a lot of background. So the delta F over F might not be as, or the self might not be as obvious from the raw movie. So if you click OK, we'll basically close out. And what you can do then is open up the interface one more time. And then once you know what kind of settings you want, you can go to this basically pre-processing GUI step. And what this entails is then you can basically select any movies that you want here to run. And you can basically just continually, and even if you already had movies here, you can go into the add folders and just add a new movie again. So what this looks like here is that I'm not going to run the entire thing because for time reasons I already pre-run it, but I'm going to show you what the interface looks like. Right. And so the first thing that will pop up is there'll be basically a list of the different main steps that you want to do and the order that you want to do them in. So oftentimes that includes a motion correction, cropping out borders from the motion, doing delta F over F or delta F over the standard deviation, fixing drop frames if you have older Scopex movies, and then downsampling in time. So some people might want to, if you have movies that are at a higher resolution than you need for downstream analysis, you might want to move that above, or the same thing with the time if for whatever reason you have that. But in either case, the movies that the options that you select here are the ones that will be run later on downstream. So let's do that. And so you do that step, and then if you click enter, what will happen is there'll be a second thing that'll pop up, and this will basically ask you what steps do you want to save at. So usually most people will see at the last step, but for some reason, either for debug purposes or you want to use intermediate steps for some other types of analysis. So for example, if you are downsampling in time, but you also want the undownsampled movie, you can also have that as well. So the first thing will pop up is start some pre-processing settings. So it'll ask you to select the frames that you want to pre-process. And so for us, what that will entail, since we're not going to run the whole movie, you can also just run a subset of the movies if that's what you're interested in. It'll ask you again for what's the regular expression for the file that you're analyzing. And so in our case, for example, I have this cat recording that we can use to, that basically is the name of most of the base files. And then I'll ask you some other settings, and also if you want to save in NWB format or in just the plain HDF5 format. So if you click this, one of the things that it'll ask you is, do you want to load the previous settings? So as I said before, what you can do is you can basically load settings from a prior situation. So if we go in and so I can find. So what you can do is that if you do that, it'll load in the settings file. And what we'll have here is we'll have the same settings that we had before. And again, if you highlight over any of them, it'll show you a tooltip to kind of explain in more detail. But most of them are evident from the name. So basically, you can go in and you can change whatever settings you want for the filtering, for the different steps. And then these will end up being saved within either the HDF5 file or the NWB file. So the idea is that you can actually just use the file itself. So someone just gives you the file without any of the processing. I basically store as a JSON string this entire settings information within the HTML5 or NWB, so that basically it can be used as providence later in cases where you want to analyze movies in the same fashion or figure out what processing someone did on a set of movies. All right. And so it's going to show you the same feature again, where you're going to basically see popped up a series of options, and most of the time you can just select this one, so that you can, for every single movie, you'll set the coordinates. So again, you'll go in, select it, it'll go through and do the processing again as it did before. And then in this case, so before I had previously saved, say, in the HTML5 format, but what it'll do in this case, when you select that option, is it'll go out and save in the NWB format. And so basically, the downstream, many of the downstream tools are adding support for NWB, and then we're basically going to have tighter and tighter integration in the future, so that's even easier. So what that looks like is indicated here. So this is an example movie that was processed. You can see selectivity, and what it'll do is if you have many different movies, they'll do this for all the movies. So run analysis on all the movies. So you can walk away, do experiments, or whatever, and then come back and basically check all the movies, and then the ones that aren't good, you can go back and reanalyze them or figure out what went wrong. All right. So let me hop over to, so once you've run the pre-processing, what that'll look like in terms of the actual files that are output is if you go in and you look at the actual class, so the example folder files that you can download are put in the data folder. And the way that this is generally organized is any of those external repos are all downloaded here. And so if you need to modify or change something in those, you can look here, or the zip files will also be here if you need something goes wrong or something's accidentally deleted. And then the different package functions are in either the package or in this underlying folder. And then there's actually a lot of times many different settings and other things that are stored in this private folder, just so that basically it's hidden from MATLAB in that sense. So if we go into here and into here, what we'll see is that within this folder, we have both our HTML5 as well as our NWB file that we just analyzed right now, as well as the other pre-processing information. And so for example, if you're running the CMF or other analysis, those are stored as map files. And they're also, if you select the option, can be stored as NWB files. Okay. And so one of the other steps is that a lot of times for GRIN or other imaging, you have parts of the movie that you don't particularly want. And so what you want to do is there's this next step right after the pre-processing called modified movies. And what that allows you to do is if you load this in, it'll always ask you for this video player. It'll give you a set of settings, and it'll more or less evenly spaced throughout the movie, pop up an interface using, in this case, image J, that will give you the option to more or less select a region that you want to include. So for example, if you're using a GRIN lens and part of the GRIN lens, the edge of the GRIN lens is in the movie, and you don't want to include the part that's outside the GRIN lens, because sometimes those can fluctuate, and it can basically mess with a little bit of the motion or of the cell extraction. You can do that, and so basically what you can do is you can just do it once. So you say yes here, you can draw many different ROIs if you want to do like multiple selections, or if you just say done, it'll say okay, and then it'll go through and it'll load all those movies. And so if you have like say 20 movies, it'll show you all of that interface at once, and then you can select everything and then walk away and then come back, and it'll have basically gone through and added in this case, zeros for all the places where there's where you don't want it. And basically what this means is that, for example, in cell extraction, it'll just ignore those regions. And that's and the zeros are separate from the nan border that's added during motion correction, so that you can go back and separate those two later if you need. And so when you do that, what will happen is it actually ends up getting stored. So your initial file is called this, where it has kind of some of your processing steps here in the file name. And then after you do the, say, manual cropping, it'll add another file with that name there. And so then one of the main things is the cell extraction. So if you select this, what you select here will basically partially matter in terms of what you'll do the analysis, and then you can select whatever folders you want to run, as indicated here. And so when this pops up, it basically gives you a list of options. And so the nice thing is that you can actually just run, if you have like 10 movies and you really want to quickly compare the different methods, you can basically select as many of the methods as you want, and then it'll run them all and all the movies in one go, and then you can come back later. And so I'm just going to show for all the main ones that are on the public repo, which is the PCISA, CMF, and CMFE. And then these other two should be on there sometime in the future. All right, and so when it does that, it's going to, again, pop up some questions. And the main one is basically what it wants you to look for, and then several other settings here that kind of depends on parallelization and if it's looking for HDF5 file, what the data set name is. And then if you want to save in the NWB format. So for PCISA, there's relatively few parameters. So again, you can go look at the original paper from Mark's lab to know what they mean, but the kind of main one is this new parameter to determine the spatial versus temporal aspects of PCISA. And so you can select OK. For CNMF, there's a series of different parameters that are available. And then this will slightly be changed actually, so you can have full access to all the parameters, but these are the main ones. And then there's the one for the cell size or diameter, which you can set here, or if you leave it blank, it'll pop up an interface so you can select the size of the cell yourself. So if you say OK, then it'll pop up the next thing for the CNMFE. And the CNMFE is slightly different at the moment, and that it'll show you some of these main features. But what really matters is that if this is left as default, when you say OK, what it'll do is it'll actually pop up the full set of settings, and they're all annotated so that you basically can click all the knobs you need, and if needed, you can basically load in a previous CMFE setting that you know worked for you, and just drop that in here. And for these particular files, they're more or less loaded in. So if you go to this base function, and you go over here to settings, the CMFE setting is located there, so you can basically just alter that as needed. Okay, so you basically just close it, and then the last thing they'll do is for the ROI analysis, it'll also pop that up. And if you can kind of see that here for the ROI analysis, it's basically asking you how much you want to threshold the filters from a particular other algorithm before running it on the movie. And then it'll ask you what algorithm do you want to use for the ROI. So because ROI isn't in and of itself automated, you want to go through and do that yourself. So you say OK. For PCISA, there's several things that you can select, which is basically just saying how many PCs and how many ICs do you want for each of your different, in this case, animals that you have in your movie. And then in the case of CNMF, since it wants the actual size, estimated size of the cell, you can basically go through and do that as well here, where you can select the size of the cell and then kind of the estimated distance between them. So I'm not actually going to let this run. And then the same thing that will happen is if you want to do the components for the CNMF. Okay, so I'm not actually going to run it just for the sake of time. But once you've done that and run it on your different movies, you'll basically get a bunch of the different files for each of the different cell extraction algorithms will be output. And so you get it for CNMF, CNMFE, PCISA, and others. And so if you have it in NWB format, it'll be stored that way. And then if it's in the mat format, for example, you take the CMF and drop it in, what that'll look like is if you load that in, it'll basically be a structure, and that structure will contain many different outputs from that particular algorithm. And so in the case, say, of we want to compare the extracted signals, and there's the estimated signals are the ones that are from the delta F over F. But in either case, those are basically those will be indicated as they are here. So you can kind of manipulate them really quickly with the mat file and just dropping them in. Or if you're using through any of the GUIs, like other StreetGP or the others that are available, you can also load them in using NWB files. Okay. So if we load the interface back in again, one of the next things that usually you quick want to do is just to compare it to the movie itself. And so when you do that, what that looks like is indicated here, where you can then select the video player. And then you can select basically how much of a movie do you want to show the signals from. And there's other options here, but the main thing that really matters is how many frames you want to look at. And do you want to just create out from all the outputs in a movie if you want to quickly check that you're not missing cells. So if you say okay, what it'll do is it'll go through and it'll load in whatever particular algorithm that you selected on the main screen. It'll load that in, and then it'll use that as a basis for creating the movie. And so you basically can see that here, where you have each of these individual outlines is indicating where an individual cell was found, in this case in the CMF algorithm. And for example, if something was run non-optimally, what you can then do is go in and see, okay, if I'm missing cells here, maybe I just need to run it with slightly different parameters. But this is like a really quick way that you can check to see, are you finding all the cells in the movie, or are things being potentially missed based off of the parameters that you had by default. And if you have multiple movies, it'll basically do this all for the multiple movies and then show you each one successively, so you can check all your movies at once. Okay, so once you've done that, for many of the algorithms, you basically want to do manual self-extraction afterwards. And so what that looks like is, so we're going to use the NWB format to do this, is you want to basically go through and manually sort the movies. And when you do that, what you can do is, if you have very large movies, so it'll load in the movie for part of the manual sorting. But for many people, you don't want to load in an entire movie. And if you have an HTF5 file, you can also basically load the movie from disk. And this will basically save you a lot of RAM and memory. When you do this, it's going to ask you for what the username is. So not America, but this is basically a way so that you can, if multiple people are sorting the same folder, if for some reason you want to check to make sure that people are having the same decisions on what is not a cell, you can indicate that here. And then, oh, I didn't actually load that in. So the one I actually loaded. So the way this works on the back end is that even if you have movies that are stored on a network drive or elsewhere, you can also load them in here, but piece by piece, so that if you have a really large movie that's, say, on your university's network storage, and you can mount it as a drive so Windows can see it normally, you can also load it in that way. And so this interface, what you'll see is there's kind of several main aspects, which is there's the kind of outlines of the cells and of the whole entire movie. There's basically a cut movie that's basically matched to some of the peaks here. And basically what you can go through is you can go through and basically sort through the cells that are relevant. And this is ordered by however the algorithm orders it in terms of the output. Or if there's particular cells that you have of interest, you can go through and select those cells and check to see what they look like. And so within this, there's kind of several different features. One of them is to go through and just, if you want to manually select a particular frame, and let's change the contrast so it's easier. It's easier to see this. All right. So basically what you can go through and do is you can go in, if you want to basically check how well the algorithm is performing, you can also go in and look for individual parts of the trace. How does that compare for that particular cell to the movie? As well as go back to the main interface, which is basically showing many different event peaks all at the same time. So you can go to quickly get a sense of, is something a cell or something not a cell, or how well is the cell extraction working? So within this, there's a lot of different things where, like, for example, you can go in and compare to the entire movie itself to get a sense for the context in the case, say, if there's blood vessels, other things that might not be actually cells. You can also go in and do things like pulling up where all the neighbors within a certain radius or distance. And what this will do is this will pop up an interface if there's no neighbors near that guy. So, it'll pop up all the neighbors and it'll show you the activity traces. And this is the way you can get a sense for, is there crosstalk or contamination from nearby neighbors. And so basically you can go through and do that. And once you're done, you can go through and basically say, yes, I'm finished sorting, and it'll save out your outputs. And the nice thing is that if you actually go into the underlying folder that you have, what you'll see is that if you're going through and sorting a very large movie, what I'll do is that as the movie and decisions are being made, it'll save out to this folder that basically have the name of your folder and a timestamp. And so as you make every single decision, it's going to save this out here. And then if you drag this into MATLAB, it'll give you these valid. Or if when you're loading into the interface itself, you can load this decision. So for whatever reason your computer crashes or something happens, know that you wouldn't be sitting there sorting cells for like half an hour and lose all that. So that information will all be stored for users to make sure that they can sub-access that information. All right, and so the last main part that we're talking about is the cross-section alignment. So if you go down here and select a set of movies that you want to align across days, you go in, you say, okay. Now what will happen is we'll pop up an interface that's kind of indicated here that'll kind of ask how many rounds you want to register, some of the settings for how close cells have to be in order for you to match them, what their correlation is, and several other settings that are basically explained in the interface. And so if you actually just load E1s. All right. So as running in the background, one of the other things that I wanted to mention is that there's basically a command line way of running all of these. So almost all the underlying functions to all the analyses are easily accessible and are not within the class, so that you can basically use them as needed. And so if you go to this kind of command line page within the documentation, it more or less will list you out the general commands that you can run in order to do a lot of the analysis without actually using the GUI if you basically just want to batch them or make your own custom pipelines. So let's try this one more time. All right, so what it's going to do is it's going to go through and it's going to correct and do the motion correction for all these, and then match the cells across different sessions. So again, as I was saying, if you go in and you are looking in this particular web page, it will give you a list of all this information. But the thing that you can also do is if you go to the package itself, It'll actually have this particular demo file. And if you select to edit it, you basically can go through and run each of these particular cells. And that did things like basically download the example data if you already haven't, basically setting up to load a particular movie, going through visualizing it. So there's this function called play movie that you can do to visualize particular movies, and you can either visualize the matrix directly, or you can just give it a path to your TIFF, AVI, or whatever, and visualize it that way. Sometimes you want to downsample the movie, so I'll do those steps, removing the stripes, do the motion correction as we did before, the spatial filtering, going through and doing the delta alpha ref, more of the downsampling, and then finally going down and doing the cell extraction. And so this one has the underlying function for the, say, doing the PCICA, but there's also, this will be updated so that you can also just show you how to run the CMF or CMFE using the wrapper functions for them within MATLAB. And the last parts are for the saving out the, say, the NWB files in the case of the filters or the cell extraction outputs. And then if you want to save out the actual movie itself, there's just a very simple function, and these are all be documented, that basically whatever you, if you have some particular matrix, you want to save it out, basically whatever file name you give it, or NWB, or H5, or API, it'll basically save out as that format. And then the different ways that you can run the signal sorter. So the signal sorter itself, if you just want to use that in of itself, you can just run separately without using the other parts of the GUI. And you can, for example, just feed it in an NWB file, and then you can feed it in, say, an input movie file, and then you can go through and do the sorting completely separately on your own. And then the different downstream steps to do the overlaying the movie on the image and creating setup-based movies. So basically, once you've done the cross-section alignment, what you'll see is here will be basically, so for figures, I'll show you the cells that are aligned across days. And then there'll be others that basically give you some information about how closely the alignment is, as well as showing you some example cells that are matched across all your different sessions. And in some cases, your algorithm is really good. For example, in this case with CNMF, you can actually see across data that even like the shape of the different cells is maintained. All right, so that's kind of the main overview of the GUI pipeline. And there's several other functions here that are dependent on some of the analysis that you need to do. But the underlying idea is that it allows you to load in kind of arbitrarily a number of movies that you want to analyze. Allows you to go in and visualize them. So also if you are just starting out with a new set of movies and you just want to really quickly look at all your movies, you can also just use this view movie, where it basically allow you to basically go through and view all the movies really quickly and say, yes, they look good, yes, they don't, and you can use that later to determine which folders you want to analyze. It has the ability to go in and compare many different cell extraction algorithms and run them. And then we'll be adding in a GUI that will also allow you to directly compare the different algorithms to one another. There is increasing support for NWB, both for the cell extraction side, as well as for the saving out of the movies. And as I was mentioning before, one of the nice things, both for the NWB and just in general, is that it's trying to set out the provenance of how the movies were saved. And I think at some point, maybe that'll be integrated more within a standard. It's always hard to do that with an NWB just because different methods have different underlying settings that they use to process the movies. But the way it is now, basically there's a JSON file that will store all the information about a particular movie. So if you really need to later on go back and look at a movie file and figure out what is the information that's stored in it, you can do that. So if you have, say, a particular movie that you want to go in and have an idea of, you can load it directly within the interface, or from the command line, you can go in and take this movie and get out all the information that was used for the processing. And then this basically information can be fed directly into calcium imaging analysis itself. And so as I was noting, you could basically, this command line version, you could either run it here by running each individual cell. I won't necessarily go on over that in detail, or you can basically go through this command line pipeline and basically run these individually from the website itself. So yeah, it's kind of it's a general overview of the calcium imaging analysis. And as always, I usually like to thank those that were involved, especially in the testing phase and helping with it. So again, this was developed well in Marciso's lab, and particularly those people here. So Diego is the undergrad student that helped with some of the automated classification. Lacey helped a lot with developing one of the algorithms that we should have out soon. Jones is a postdoc that did a lot of the initial testing for the class, just out of necessity partially. Mark Elvis is my advisor, and then many others that help contribute to many of the different functions and underlying classes, as indicated here. So with that, I'll end the main part of the workshop, and if anyone has any questions, I'll be around, or if needed, you can basically just shoot me an email as indicated here, and I can follow up with you if you have any questions about the package or about comparing different cell extraction methods and so on and so forth. Awesome. Thanks again, and I really kind of enjoyed what's being pushed with NWB. This hopefully should make a lot of the provenance issues and actually getting old data from people and reprocessing it, which I've had to, like, for example, from an automated cell extraction, I had to collect data from many different people, and you realize very quickly that if there was a data standard 10 years ago, you would have been saved a lot of hair pulling and figuring out, even what frame rate a movie was taken at. Oftentimes, if that's not saved, you just get given a raw TIFF file. You might not even know the frame rate, and then that can cause so many issues. So there's so many ways that I'm looking forward to NWB hopefully making it a lot easier for people to compare different things and use data that's previously available.
Sweet. Well, thanks, Biafra. That was awesome. Like so many different things. It seems like every time I think I have a full picture, there's another little GUI to adjust the contrast, and I'm like, oh my God, he's got that too.
Yeah, I feel like parse is one of those things where if this is like where you have a UI specialist that's separate from I'm just like, probably UI specialist to be like, change all this, and then when you're experimentalist, you're just like, I want it to run in batch and do this. Yeah. So it's sometimes a kind of sort of someone gives me a feedback, then I'm like, oh, okay, I'll add that in or change that.
Yeah, that's awesome. All right, so yeah, we've got a few minutes for questions. While people are formulating them, let me pull up the schedule.
Are you guys going to keep going around the world and end up having an Asian or?
I don't know. I think we'll probably just do these two time zones. The alternative time zone is tricky for us because we end up just doing it right in the middle of the night. Right. But maybe Asian. I think we actually have been getting a decent amount of interest from Asia. Particularly, we had like 37 registrants from India, which was a very pleasant surprise to see that much engagement from India. So I think if that grows, and then we had 11 from Japan and 1 from Vietnam, and we had 1 from New Zealand, 1 from Australia. So like that general time zone is starting to pick up interest. So maybe we will. Maybe we will.
Because most of the developers are in the States or in Europe.
Yeah, yeah. Most of the NWB community is in the States right now. We're trying to, broaden our reach to Europe, and that's the idea behind this hackathon, is to make it more accessible to Europeans. Because that was feedback we got from the last hackathon, that like the Europeans would be up until late at night listening to breakout sessions, so they wanted one of their own.
Right.
Yeah.
imagine it's like with the Olympic Committee and they're just trying to decide which country to give host to. Okay, so
yeah, exactly. Like who's going to bid the most, you know?
That's probably why like someone in Oceania will never actually host it, because it'll be nighttime for everybody.
Yeah. Cool. Yeah. All right. Well, so I mean, are you continuing to actively develop this platform? What's the vision for this? Are you,
Yeah.
well, one thing I'm interested in is volumetric. So when, I mean, and I know, you know, like cutting edge optical imaging technologies allow the planes to be close enough together that the ROIs are actually specified across planes. So I'm kind of curious if you have a vision for incorporating that type of data into this.
Yeah, so actually that's, so the multi-plane, that's slightly incorporated into this. So for one of our papers, we did the volumetric, or the multi-plane imaging, I would say, of the striatum. And so that was integrated in the sense that I somewhat consider each plane its own separate thing. And then I, within the class, had basically one of the modules that would combine it later for the analysis, and basically get rid of like the cells that were found across different planes and so on and so forth for the downstream. But some of the underlying functions and algorithms, so example, Cayman, I guess part of that already supports volumetric, but some of the other cell extraction methods, for example, PCICA by default is mostly made for just single plane imaging, would have to be modified. And then even the algorithms that we made should work for the volumetric, but I think part of that was out of the necessity. So kind of a lot of the features here were added in succession, like as I needed it. And at least for my postdoc work, I think for the spinal cord planning to do the volumetric, or at least the multi-plane. And so I'll probably add that integration in as it's needed, or if it's really pushed. And then, and probably general vision, I know like this has been asked by both Andreas and others, is kind of moving everything over to Python or others. That's kind of like, I think right now the main thing I'm trying to do is change it so that everything's within a package. I know a lot of MATLAB things aren't actually designed as packages, which actually turns out to be annoying. And so part of what I've been doing is trying to slowly move everything over to a package so that the namespacing is better. And then I'm basically just continually actively developing it, partially because I still need it for my own. And then we'll see if, for example, the Chan Zuckerberg initiative, I know, has ways of trying to support some tools getting further development.
Yeah, that'd be great.
For example, like even for the comparing the cell extraction methods, like I have a GUI, but there's obviously cases where if there's someone that's like a UI specialist and they can be brought on board. But the idea right now is basically to continue to develop it, and then if new algorithms come out, to incorporate those. And then hopefully there's the idea that, at least with MATLAB, you have the web apps or others, that it can be something maybe like Spike Forest, where for calcium imaging, we can have it where you can take a small segment of your movie, drop it into like a website, and then it runs all the different algorithms and then shows you a comparison all at once. And I think that would be helpful for a lot of people, because I know some ones that are still using PCICA. When I look at their data, I'm just like, oh, no, you should be using like either our algorithm or CNMFE, because you're going to have a lot of crosstalks. But I think that'll be facilitated by an easier way for people to get a sense. And I think if more things are stored in NWB, for example, that should make that drag and drop a lot easier than if it's like in some.
Yeah, totally. I totally agree. I think something analogous to Spike Forest would be really powerful. I think, what they found is that it was kind of previously thought that any, popular spike sorter will do something reasonable and probably have just about the same results, but it's not true. They have very different results. And I think if we do, I know you've started to do these comparisons, but when you do rigorous comparisons between different extraction algorithms, they sometimes have different results, and it's important to know.
Right. And I think even, maybe it was Tim Harris, I think, came by Stanford, and he was talking about like the agreement between them, and he was like, only 30% of the units would have an 80% agreement in terms of their spikes. And he's like, and this is like from like, my people at Genelia, who are like the gold standard of deciding this, and we like had a fairly large disagreement in what was being identified and like what spikes were being identified. So he's like, you know, if someone gives you the 10,000, 20,000, 30,000 units from the neuropixels, he's like, just, you can interpret some things, but he's like, maybe we need to figure out how do you figure out how robust your findings are to potential slop in the algorithms.
Yeah. Yeah.
I think for the cell extraction, that would be nice. And there's a couple of steps, even say for the automated classification, where I think it would be nice if people publish their papers, they publish how they also got rid of things that they didn't consider cells, because a lot of papers where it's like, I don't know how they got rid of things, and we don't have a really clear way in the community of reporting that, so that, but that might be important going forward.
Oh yeah, that'll definitely influence your results. Yeah, cool. Well, thanks.
Yeah, thanks again. I guess it's evening time for people.